Hi, and welcome to this instructional video on how to complete Unit Standard 25705 Task 1. There are step-by-step instructions. I've changed the dimensions on the drawing I've done. You'll just have to relate the information back to the dimensions on your drawing. This is the 60-degree branch pipe. Right, let's get started on Unit Standard 25705, Task 1. This is the 60-degree branch pipe. You're going to need drawing instruments, set squares, and a T-square, and a drawing board, and you really have to concentrate on getting this accurate. So here are the calculations that you'll be required to do. Now, these aren't the same calculations of yours, so you can swap out the numbers, but my main pipe has a 90 diameter. My branch pipe has a 50 mm diameter, and these are outside diameters. It's a length of 100 millimeters, and my material thickness is 2 millimeters. In the assessment, your measurements are different, so you will have to scale your drawing down. So your large pipe is 200 millimeters. You could scale that by 50%. So that is simply dividing everything by 2. So that's a scale of 1 to 2. So you could make your pipe, draw it actually 100 millimeters. Your branch pipe would be 50 millimeters, the same as mine, and the angle is the same. So you're going to have to scale. Now, when you do the maths, you're going to have to write the maths up on your board as if it was the true size. So your outside diameter would be 200 mil in this case, and you would have to work out using this formula of pi times the mean. Now, to find the mean, we take the outside diameter, subtract the material thickness, one material thickness, and we'll be left with a number. In my case, it's 48, and I simply multiply pi by 48, and I will get the total length of my pattern, and that is the piece of metal we require to roll up and make the branch pipe. Right, let's get started. First things first, we must draw a third angle orthographic view so that we can determine where the branch pipe meets the main pipe. We don't need to draw the whole pipe, so I'm just going to put a line across here. Let's find a center. So my pipe is 90 millimeters, so 45, so it's about here. I'll just put that there. And here is the center of my pipe. Now, as I said, I don't have to draw the whole third angle, just the area where the branch pipe connects to the main pipe. Put a mark there, put a mark here, go back and double check for accuracy, make sure it is 90, and I am spot on 90, so that's good. And now I draw in, that is the main pipe. Up here we have the branch pipe, and the branch pipe is 50 millimeters, so that's 25 millimeters either side of that center line. Determine that that is in the correct place, and it is the right width, and it is 50, so weave it over. I will gently tap my compass, and that's just brought it in a wee bit, so that will be spot on. Now what we have to do is transfer those lines up, and that is the outside of our branch pipe. Now we could finish it all off and draw the top of the pipe. What we're interested in is this part here is where this branch pipe connects with the main pipe. So I can just cut this off here, and what we're going to do is, using our compass, draw a half circle, and we're going to divide that half circle into 6 pieces. And we can do it this way by using the radius we already have and very accurately making sure our points are in the right place. I just have to carry this line up a wee bit. So by going from the horizontal line and the vertical line, I can determine my 6 points on the half circle, and each one of these straight portions in here, or this curve, but the tangent in here, would be 1/12 of the entire circle. So I can double check that those are correct by getting my 3060 and going from the center and double checking that I have these in the correct place. Okay, so this is the second method of breaking up your circle into equal parts. Righto. So let's have a look at what we've got here. This view is just drawn enough so we can determine these points here. So to get those, we will bring these points that we've put at the top down to cut through the main pipe. So from this view, we have determined where the branch pipe cuts the main pipe. So we have to now draw that as if it was turned at 90 degrees. So let's carry this line across. So this is the center line of our main pipe. And there is the top of our main pipe. Now we're going to take each one of these lines across, that's the top, down to here, take that across as well, next one down, take that across, and this is the outside of our branch pipe, take that across. Now we don't have a determined length for our main pipe, so let's just make it anything we like. So we'll drop him down to there and drop him down to there. Now we have the branch, and the branch is going out at 60 degrees. So I'm going to put my branch out here to the right at 60 degrees, and this corner here is 60 degrees, and randomly somewhere along this pipe, in the middle is probably a good place, roughly in the middle, I'm going to draw a line, and this is the center line for my branch pipe. Now because I haven't altered my compass from doing this part of the branch pipe, so my branch pipe will be on here, so I can draw a circle. So you'll be drawing these as construction lines quite lightly. I have to draw them slightly darker so they'll show up in the film. And we just take that down. So this is the outside of our branch pipe. Now our branch pipe on the outside is 100 millimeters long, so I can measure that. 100 millimeters, and that is there. And I can now, using the 30-degree end, make a line perpendicular to the center line, and that is the end of our pipe. So let's draw that in dark so we can see what we're dealing with. Remember, the length is not stated. Here is the center line, we'll just draw that in. So the assessor will be looking to see center lines to show that you understand what you're doing. We have this half circle drawn at the top, and with this one also we divide into the 6 pieces. Now you can do that as I'm doing with the compass, or you can use your 3060 again. Because it's already on a 60-degree angle, it will take a bit of maneuvering. So of course this one will be straight vertical, this one's on an angle, here we go, that's there, that will go there, that will show up there, and of course if this one is vertical, this one must be horizontal. So there, that's those 2 ways of dividing that circle into 6. As we did on this side, we just have to transfer those lines all the way down. So where they meet on the circle, we're going to take those all the way down, all the way down, all the way down, and all the way down. And of course we have our center. So we have to now relate these lines to these points here. So I've already drawn the lines across. I'll just draw those in darker now. So the green lines, or the lines I've put on here, we're going to bring across. And that one there. Righto, so now we have them. We just have to step it off. So it's just across one and down one, across one and down one, across one and down one, across one and up one, across one and up one, and across one and up one. And I will draw that in with my French curve here, making sure that I get 3 points touching. And that is where our branch pipe intercepts. Now these points are very important. You don't have to draw the line in, but you must identify where they meet. So to draw our pattern, we simply take lines off perpendicular to our center line. So because the top is cut square, there's nothing fancy to do there. We just take a line straight up there. Here's my maths again. So my length of the pattern is 150.72. Now you will work yours out to the full size and then have to reduce the number by whatever you've scaled it to. So if you're scaling it 1 to 2, you'll just halve the number. So mine's 150.75. So I will draw a line in here just randomly and go 150.75, which is roughly about there. I can take that line, join them up, and I'm going to come down here. Now this view is in the way, so I'll just rub out what we don't need, remove it. And what we need to do now is these points that we've identified here, by going across one and down one, across one and down one, then across one and up one, across and up one, across and up one. These points here now have to be transferred. So we've got 0, 1, 2, 3, 4, 5, 6. And we'll take those across. So there goes 0, goes 1, and they're very close together. There goes 2, and again very close together. 3 comes in inside, 4 comes inside, and 6. Now we're going to have to number those. So we have 0, 1, 2, 3, 4, 5, and 6. Those numbers are important. So we've got our total length. Now we have to divide our total length into 12 parts. We have to divide our total length into 12 parts, and so we do that by just randomly putting a line in here, and it can go anywhere, it's not important, any length, and we need to divide this line into 12 equal parts. This is 150.72, so if I just put 150 divided by 12, and that equals 12.5. So I'm going to set my compass close to 12.5, and if it's accidentally 13, it doesn't matter because we'll correct it all when we get onto here. So I step off 12, 1, being very accurate that I hit the center each time. These lines have to be drawn extremely accurately. The assessor will be looking for that. So the actual length, I don't know the gap. It's some between 12 and 13 millimeters. Doesn't really matter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is our last one. This is a handy exercise to do. This comes in extremely useful in the workshop should you need to divide a length into 7, 8, 9, 10. Doesn't matter how many parts, 13, 14. I'm going to simply get two set squares, and I'm going to join up those last 2 points. So this point here, the first point on our pattern, and the last line here. So if I join that, now I'm going to hold the bottom one. You can use two rulers or two set squares, whatever works, but we're going to slide along this way, so make sure you can sort of get to the end. Yep. Right. So we're going to come back here. Right, the end point of my pattern, or the start point of my pattern in this case, end point of that line, and we have that, and then we go. So as you can see, I'm marking the line here. I'm holding the bottom set square firmly. It's not moving. If it does move, just go back and start again. But this is an extremely accurate way of getting anything divided into equal parts if you can't set your compass right. The other way is just keep stepping it off 12 times with a compass or dividers until you get it right. But that relies a lot on you hitting the mark each time. So if you make an error on the first one, all you're going to do is carry that error on all the way down. So there we have our pattern now divided into 12 equal parts. Let's put those lines in. Let's number these. So we've got 0, 1, 2, 3, 4, 5, 6, and we'll go back 5, 4, 3, 2, 1, and back to 0. So we're going to start at 0, simply going to do a long one, an up or down one. If I want to, I can start at the 6. So if I start at 6, I'll come along and go up 1, 5, along and up 1, 4 goes to 3, and I go to 2. But I'll stick with these numbers we've done here to avoid confusion. Normally we would put the seam on the shortest side. So we go 0 to 1, 0 to 2, along 3, 4, 5, 6, 5, 4, 3, 2, 1, 0. We can do it the other way. If I change these numbers to 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We would then have our pattern dots going the other way, which would then be 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. And I'll draw both of those in. So I use my French curves. I just now have to join those dots. So it's almost a straight line for 0, 1, 2. So make sure 3 dots are touching. And that will take us to 0. And I could have to join the pattern up there. And if I'm doing it for the welders, we would do it this way. So it's exactly the same curvature, but it just means that the seam is on the shorter side. And there's another reason for doing it this way, is that if you have to cut it out by hand using tin snips or shears, it is a lot harder cutting into these concave areas, and it's easier to go around the outside of this red line. So it's your choice as to which version of the pattern you do. The shorter one for a welder, and that is unit 25705 task 1 completed. You only use one of these methods. Don't forget to put your name on it, and don't forget to put any other information, any maths calculations that are required, and any dimensioning that is required. Sorry, there you go, the 60-degree branch pipe penetration development. Once you've completed the pattern, you may be asked to cut it out and roll it up. So simply photocopy off the pattern, cut it out with scissors, and now we're going to roll it up. Now the secret with rolling up paper, just get a sharp edge and just pull it through, and it will automatically just forming itself up. And when you've curled it up, sellotape it together. Show that to the assessor. I just happen to have a piece of non-drainage pipe here, and that will fit on perfectly. Okay, so there's our pattern development here, our cut out and rolled up item, and as you can see, it fits on the pipe.